Chapter 12. Specifically today we're going to look at lesson 12.1, estimating limits graphically. So we've seen some limits specifically on lesson 1.3. Well, we're going to bring them back as an intro to some calculus here. We're going to look at today one-sided limits and two-sided limits. So the first thing that comes up on number 1 is it says estimate the limit as x approaches -7 of 4x plus 1 using a graph. And I have one here for you, but support your conjecture using a table of values. And I want to make sure you know how to do this if you were at home on your own calculator. What you would do when you're estimating a limit is the inside right here, that refers to f of x. So normally this would be written, if you remember, in the format of the limit of f of x as x approaches some value. That's normally how we would write it, and then we would say whatever it equals. So notice here what's happened is I have substituted for f of x with this 4x plus 1 right there. So that is f of x as I shown right there. That is f of x. So what I'll do here on my Desmos is I'm just going to type in f of x equals 4x plus 1. And I'm going to scoot this over just a hair so we can see what's happening. And so there's our graph. And we want to know specifically what's happening at -7. And so I could look in this graph. I could just kind of zoom it in here. Let me make sure. I want to be able to see -7 specifically. So I'm just going to go from -10 over, and then on the y values, let's see here. It looks like we need to get lower. I'm going to change this to a -30. Okay, so here's -7, and we want, let me slide out, let's see if it'll ever show a -7. Well, it doesn't seem to do so. At -7, you could come over here, or we can just touch the graph. At -7, it appears to be -27, and that would be our answer for this limit. I'll walk you through why. But if you needed to get a table, what you can do here is, I believe if you hit edit and hit that table, what's going to happen is the values will pull up. Now when we do a limit, you want to be approaching that value from both sides of the graph. What do I mean? Well, from the left of the graph we have a value -8. I'm going to put -7 right there. And from the right side, -6 would be the next number. And so you just want to pick numbers that get closer and closer to the value of -7. So you can kind of see how as I go, these values are getting closer and closer, and that's what you would continue to do. So we'll have like -7.1, -7.01, and you can kind of get an idea of what I'm doing here maybe. -6.99 and -6.9. So as the graph closes in closer and closer, we get finally to the value of, well, where is it? I don't know where -7 went. Maybe if I zoomed in here, you could see these values. Oh, there it is. And now I'll zoom back out. Well, that didn't work. One more time. Well, that doesn't seem to be working, but you can see as we get closer and closer, it's approaching -27. And so that would be our solution here to to this limit. It would be -27. Not only does the function exist at that point, but the limit means that's where the graph approaches. As you close in on that point, here's -7 right here. As the graph approaches it both from the right side and the left side, this graph is approaching that point, which happens to be -27. And so that would be our answer. So the limit as, I could say f of x there, but I'll write 4x plus 1. As x approaches -7, the answer is -27. Now, it won't always be the function on the graph, as we'll see later. But this first one's really simple. Now, I'll let you try one. We'll call this DOL number 1.